this function, we need to determine the x and the y intercepts. Which one do you want to solve for first? The x-intercepts. So if you find the x-intercepts, you substitute what in? 0 for the y value. So we said 0 equals x minus 2 squared times x plus 1. And so we end up getting what? 2 comma 0 and negative 1 comma 0. So there's my x-intercepts. And then to find our y-intercepts, what do? We substitute 0 in for x. We substitute 0 in for x. And when I do that, I end up basically finding f of 0. So I end up with negative 2 quantity squared and then times 1, right? And so what is negative 2 quantity squared? 4. So my ordered pair is 0 comma 4. So that's what my y-intercept is. Pretty good? All right, let's look at the next one. Determine the equation of the horizontal and vertical asymptotes. Horizontal asymptotes are when I take a limit to what? Negative infinity and positive infinity. Am I going to get one? No. Vertical asymptotes is a number over 0. Am I going to get anything? No, I got nothing going on there, so none. All right, let's look at number 3. Determine the first and second derivative of the function. So to find the first, we're going to take a derivative. What are we going to use? We're going to use the chain rule as well as the what rule? The product rule. So what's the derivative of my first? What comes out front? 2. And then times x minus 2. And then times 1, but that doesn't matter. And then times the second of x plus 1. And then plus, what's the derivative of my second? 1. And then times x minus 2 squared. All right. Now, you could leave it like that. However, I'm going to go ahead and FOIL because it's going to make your life a little bit easier in the second one. All right. So let's FOIL this thing and combine. So I end up getting 2 times. What does that FOIL to? X squared minus x and then minus 2. And then plus, what does this one FOIL to? X squared minus 4x plus 4. And so I distribute my 2 and then combine like terms. So f prime is equal to how many x squareds? 3x squareds. And then I have a negative 2x and a negative 4x, which becomes what? Negative 6x. And then I have a negative 4 and a positive 4. What happens? They cancel, so that's cool. And then from there, I can easily find a second derivative. Do you see why I simplified that one before I took a second derivative? Okay, it's going to make your life a little easier. All right, so f double prime would end up with what? 6x minus 6, right? 6. All right. So to part 4, it says complete a sign analysis of f prime to determine the intervals when it's increasing or decreasing. So what do I need to take? I need to take f prime and do what? Set it equals 0. When I do that, what do I find? I find critical numbers. All right, what could I factor out? A 3x. So now I'm left with 3x times x minus 2. And so I end up getting x is equal to 0 and x is equal to 2. So what are my intervals? Negative infinity to 0 and 0 to 2 and 2 to infinity. So if I substitute in something between negative infinity and 0, like negative 1 sounds great, what would that give me? F prime being what? Positive. And then if I substitute in something between 0 and 2, like 1 sounds great, what would I get? A negative, so f prime would be negative. And then 2 to infinity, that would be a positive. So when is my function increasing? When is f increasing? Negative infinity is 0 and 2 to infinity. When is f decreasing? 0 to 2. Now, if it said justify my answer, what would be my justification? Because f prime is positive and because f prime is negative. All right, good. Let's determine any relative minimums or maximums. Let's do a relative min. Let's see if we have any of those guys. Do I have a relative minimum? Where? At 2 comma something, right? Why? Let's go with my justification first. Because f prime changes from what? Negative to positive. All right. All right, so how do I get my other thingy? I substitute back into the original. When I substitute back into the original, what do I get? Right here, guys. I get 0, right? Because 2 minus 2 is 0. 0 times anything is going to be 0. So I have a relative minimum right there. Because f prime changes from negative to positive. And then relative max. Where do I have a relative max going on? X equals 0. So if I substitute in 0, what would I end up getting? I end up getting 4. So I have a relative max of 0 comma 4. Why? Because f prime changes from what? Positive to negative. All right. Second derivative. All right, second derivative. So what do I need to find first? I have my second derivative. So what am I going to do to it? I'm going to set it equal to 0. Can I factor anything out? I could factor out a 6. So what do I get? 6 times x minus 1. I'm going to set that thing equal to 0. And so I get x equals 1. And that is a what? A p-poi. A p-poi. So what are my intervals? Negative infinity to 1 and 1 to infinity. All right. So I got that going on. So if I substitute something in between, like, I don't know, 0 sounds great. What do I get? F double prime is what? F double prime is negative. And then if I substitute in something between 1 and infinity, what do I get? I get f double prime is greater than 0. Which means what? What's my concave down? Negative infinity to 1. What would be my justification? Because f double prime is less than 0. All right. And then when am I concave up? From 1 to infinity, because f double prime is greater than 0. F double prime is positive. All right. Do I have any points of inflection? Yeah, I sure do. Where is my point of inflection? At 1 comma something. Now, how do I get to that other something? I substitute back into the original. So when I substitute that back into the original, what do I get? I get 2. And so that is a point of inflection. What would be my justification for it? Okay, I could say it that way, but I actually have my second derivative in this one. So what would I say? I would say f double prime of x changes sign. All right? So now we're going to sketch it. So I have some points going on, do I not? So what points were I given? I got negative 1 comma 0, and that was just a what? That was just an x-intercept. And what else do I know? I know 2 comma 0. What was that? It's an x-intercept as well as something else. That's a relative min. All right. What else do we know? 0 comma 4 is a what? That's a y-intercept as well as something else. A relative max. We know something else. 1 comma 2 is going to be our what? Our point of inflection. All right. All right, now let's sketch it. Whoopsies. I just put it in there. All right, so now let's talk about concavities and when f prime is what. So when we're talking about concavity, from negative infinity to 1, what was my concavity? It was concave down, so that's what it looks like, true? And then from anywhere from negative infinity to 0, what was my slope? It was increasing, it was positive. So it should look something like that. And then what happens from 0 to 1? It was what? Slope was down, right? And then what was your concavity from 1 to infinity? It was concave up. So it should look something like that. All right. See how we worked that? All right. Make it smooth. Are not going to be a whole lot of math. It's going to be a lot of thinking. All right. I am not going to be writing much down. but we're going to be thinking a lot. All right? Calculus isn't hard. It's just what? Different way of thinking. I'm hopefully going to train it. Okay? So here we go. So I need to sketch a smooth curve given that the function f such that f prime is always greater than 0 and f double prime is always less than 0. So show me f double prime is less than 0. When is f prime greater than 0? It's which part? It's that part. There it is. Okay. That's what I'm saying. That's what I'm saying. All right. Pretty good? All right. Let's do some more. We're warming up. We're warming up. Here we go. So on part B, it says that f of 1 is equal to 0. So f of 1 is equal to 0. Let's put a little dot there. And then it says f prime of 0, or f prime of x is less than 0 for when x is less than 1. What does that mean? It's decreasing. Okay, it's decreasing there. And then what does this mean? F prime is what? Greater than 0 for what? X is greater than 1. So there's a lot of different options here. All right, because what does it not talk about? It doesn't talk about concavity. So it could be something like this. It could even be something like this. Wouldn't those have the same slopes? It could even be something like that. All right? Because does it say it's differentiable the entire time? No. All right? So you actually have some leeway on that one. It's only talking about the first derivative. Okay? Let's keep moving. Let's look at this one. So it says f of 1 is equal to negative 2. So let's put that. All right. And then it says what? F double prime is less than 0 when x is less than 1. So I am concave down for this whole portion. You following me? And then what does this one say? I'm concave up this whole portion. All right. So let's just use your hand. What's concave down look like? There you go. What's concave up look like? There you go. Let's draw it. All right. Pretty good. Does it tell you anything about the slopes? It doesn't. All right. Did it have to look exactly like that? It didn't on that one. All right. It didn't have to look exactly like that. Now let's look at part D. We're going to get closer to what we have to look at. So on part D, it says f of negative 2 is 8. So let's put a little dot there. F of 0 is 4. So let's put a little dot there. F of 2 is 0. Let's put a little dot there. And then it's talking about concavity on this next line. So it says it's concave up from x is greater than 0. So I am concave up this whole time. All right? See how we wrote that? And then what does this say? What does this thing say? F prime of 2 is equal to f prime of negative 2, which is equal to 0. What does that mean?
It's going to be relative minimum.
They are going to be relative mins or maxes probably. Okay, they are critical numbers. All right, so I have horizontal tangents going on right there. All right, I got horizontal tangents going on. Okay? All right, let's keep moving. This next one says f prime is less than 0 for when absolute value x is less than 2. What does that mean? The slopes are what? It's decreasing. So f is decreasing. From negative infinity to negative 2. And then what else? Oh, when did I do that? I did that backwards. F is decreasing from negative 2 to 2. All right. So there is where I'm decreasing. All right. All right, this next part. This next part says what? F double prime is less than 0 for when x is less than 0. So for this whole portion, I am concave down. I am concave down. All right. Now, this next portion. So f prime is greater than 0 for when absolute value of x is greater than 2. That's the way I read it accidentally. So this means what? F is increasing anything greater than 2 and increasing from when what? Less than negative 2. All right. All right. Now let's play. So we're concave down. So what does concave down look like? Right there, right? And then increasing means it's that portion. All right. So we go up. We go up. And then I have a horizontal tangent. And then I'm still concave down, but which way am I going now? I'm going down. And then this next portion, I'm what? Concave up. But which way am I going still? I'm still decreasing, so I'm going down. And then what? And then I'm concave up again. All right? So some graph that kind of looks like that. Something like that would be a really good test question. My goodness. On E, if you talk about the increasing and decreasing, I'd go ahead and mark them. Mark them just like that. And then say when it's concave up and concave down. Put the little points that they give you. Relative max is going to go from increasing to decreasing, or f prime positive to f prime negative, and so forth. And so you're going to get a little sketch like that. All right, hopefully that one wasn't too bad at all. All right, let's look at part F. Let's look at part F. So now we have symmetry. That's kind of nice. And then it says f of 0 is 2, so you put that. You have a horizontal asymptote. You have vertical asymptotes going on. What makes a horizontal asymptote of 0? Y equals 0?
When the bottom power is bigger than the top.
The bottom power is bigger. All right. So anyway, that could be something that might be on there as well. So and then it says it's increasing. So from here to here and here to here. And then it says it's decreasing from here to here and here to here. Right. And then it's concavities going on. So if it's concave up, it's decreasing, increasing. It should look like that. All right. If it's concave down, right? If you're in between here, if it's concave down, but it's also what? It's also decreasing. All right. So that's why it's hugging that way. And then this is concave down again, but this part is increasing. All right. All right. It says it's increasing on those intervals and decreasing on that little bit of an interval. But then it says its tangent is an undefined slope at the origin. What is an undefined slope? It's when it's going what? It's going vertically. Right? It's going vertically. But then it also says at the very end, it says it's no concavity either. All right, so we should have something going on there. But then it says it's concave up except at x equals 0. So everything is doing this. Everything's doing this. And that could almost be done right there. All right, that's almost done right there. And so when we have this, we got it going on right there. All right, so concave up and increasing, concave up decreasing, concave up increasing. We still have a relative minimum. All right, pretty good. All right.